Burring and deburring, everything you should know. If you regularly shop for parts, you have probably dealt with unwanted burrs on workpieces. Burrs are imperfections that not only look unsightly but can considerably reduce the safety and functionality of the part. As a result, they need to be removed to create smooth, quality parts. What is deburring? Deburring is a technique used to get rid of unwanted burrs from metal products. Ideally, deburring is a secondary machining process meant to enhance the final appearance of a part by removing unwanted pieces and raised edges of the material. Burrs can be created from piercing, cutting, compressing, and bending materials. A deburring machine is used to remove burrs through thermal, electrochemical, or mechanical methods. Causes of burrs. Burrs are quite common during machining processes. They can appear at any given stage of machining: forming, stamping, engraving, turning, drilling, plasma cutting, sintering, casting, grinding, laser cutting, drilling. Types of burrs. Whenever burrs occur, they take different shapes and appearances, which define their types. These are the common types of burrs that occur in machined parts. Rollover burrs. These burrs appear like tiny parts of metal that project from the product. They are the most common of all types of burrs. A rollover burr is formed when the material is pushed when being cut. This results in a burr with a round edge. This type of burr is quite difficult to remove owing to its shape. Fortunately, with the right technique and tool, it is easier to remove. Poisson burrs. This type of burr is formed when the excess material corrects at the end of the part and extends sideways. It is characterized by a rough and raised edge. Since it is thin, it is easier to remove with the regular deburring tool. Breakout burrs. Breakout burrs are common with sheet metal. They are caused by the material being ripped or fractured by the exit point of the cutting tool. These burrs can be large and have a unique upswelling shape. In most cases, a combination of techniques and tools is required to get rid of them. Tear burrs. This type of burr results from the tearing of material when being cut. It has an irregular and jagged edge. You can remove this burr by using an aggressive deburring tool. Oxide burrs. These are also called heat-affected burrs that are caused by the heat generated during the cutting process. As a result, the metal is oxidized, causing a protruding edge. To get rid of oxide burrs, you need to combine both chemical and mechanical techniques to deal with oxidation. Microburrs. These are minute burrs that might not be visible to the human eye. Although they do not seem to be a major problem, if not removed, they can cause serious functional issues. These burrs are removed with the help of polishing techniques and precision tools. Importance of deburring. A part that has burrs is flawed. This is because burrs can compromise the durability, safety, and functionality of the part. These are some of the quality issues that are caused by burrs. Compromised fracture resistance, fastener damage, material failure and cracks, lubrication issues, increased surface wear, diminished safety, diminished corrosion resistance. By deburring, you get rid of these defects to create a more functional, better aesthetics, and safer part. Also, the process gets rid of grinding and sanding. When deburring is done correctly, it reduces material consumption and improves productivity. You should note that deburring is done as part of the surface finishing process that involves other methods, such as edge breaking, descaling, graining, and deslagging. Burrs can pose serious safety hazards as sharp edges pierce through electrical cables and pressurized lines. Also, people handling such burrs can be harmed. In machining, finishing can take up to 35% of the labor costs. Since finishing is part of quality assurance, by deburring parts, you can ensure higher quality parts for your customers. Deburring media. Various forms of abrasive media are widely used in deburring. These include organic compounds, ceramics, plastics, and steel. The deburring media is available in a range of sizes and shapes. The media is used to cut, scratch, and prevent parts from joining together. Ceramic media. Ceramics are used in deburring various types of plastics and metals. It can help provide a variety of finishes at different speeds. The fact that ceramics have excellent hardness, they are used to deburr hard metals. Plastic media. This type of media is meant for specific applications, Since plastics have low density, they are suitable for general-purpose deburring. Also, they can be used for deburring ferrous and non-ferrous metals. Synthetic media. Usually, synthetics contain up to 70% abrasives, which can be emery, silicon carbide, and alumina. Since abrasives are embedded with soft material, the material erodes, leaving the abrasive to deburr the surface. Steel media. This type of media is best suited for light deburring. Although it is expensive, it is still used because of its cleanliness and reduced attrition rate. Organic media. Some examples of organic media include corn cob and walnuts. This type of media absorbs oil and water, making it suitable for drying applications. Top deburring methods. There are different deburring methods selected based on factors such as part geometry, cost, product volume, location of burrs, and material. Conventional methods include mechanical and manual deburring. Thermal and electrochemical deburring techniques are meant for specific applications. Manual deburring. In this case, mechanized or handheld tools such as grinders, sanders, and files are used. Since the procedure is localized, it has no impact on other areas of the part. Being a time-consuming method, it is widely used in small machine shops. To get the best results, it needs skillful craftsmanship. Mechanical deburring. This form of deburring comprises multiple methods such as grinding, tumbling, vibratory, sanding, and rolling. The method is more popular than manual deburring because it is efficient. Sanding involves the use of different abrasives such as zirconia compounds, silicon carbide, and aluminum oxide. These abrasives can be available in the form of discs, wheels, belts, and sheets. The rotating or reciprocating motion of abrasives eliminates burrs from the surface of the part. Vibratory deburring involves the use of vibration motion machines loaded with abrasive media. The machine then vibrates to produce motion. This method is best suited for complex parts or mass production. Tumbling involves the use of a centrifugal or vibrating container that contains liquids and abrasives. The act of rubbing and moving against the workpiece helps get rid of burrs. The good thing about this method is that it does not scratch the surface of the part and results in a great surface finish. Mechanical deburring by rolling or grinding provides a high-quality finish with minimal effort. Although it has some similarities with manual deburring, it is more cost-efficient and suited for mass production. Punch deburring. This technique involves the use of punching machines to get rid of burrs. You need multiple types of dies to carry out punch mold work. This method results in higher productivity and better efficiency as compared to manual deburring. However, it needs special tools, and it is not suitable for complex structures. Hole deburring. The technique is applicable when an inner part of a hole requires deburring. A wide range of tools are used, such as cutting tools. The tool gets into the hole and cuts burr without creating any damage or scratches. Brushing. A special type of brush is used to clean the surface. This method is similar to deburring with sandpaper. Since the brush is mounted on a machine tool, the process becomes easier and more efficient. Electrochemical deburring. The technique is also known as electropolishing. It is ideal for removing burrs from areas that are inaccessible to other deburring techniques. The technique is the reverse of plating. Rather than adding material, it gets rid of it. Thermal deburring. With this method, burrs are eliminated through burning of material. The process takes place in a regulated combustion chamber. This method is suitable for mass production because it is quick and can deburr multiple parts at any given time. Water jet deburring. The technique uses pressurized water to remove debris and burrs from a part. Water pressure is controlled to avoid damaging the part. However, this method cannot get rid of larger burrs lest it damages the part.